Assalamualaikum again dan good afternoon pada pukul 12 ah. We are into our second session. Okay, second session for this RC punya staircase design. Somebody WhatsApp tadi kata please upload the lecture on Monday. Okay. Saya pun dah terlupa nak upload. Okay. I will upload the lectures yang we had last Monday. Okay. Saya check Thursday last week dah upload, cuma Monday saya belum upload lagi. So I will do that lepas kelas nantilah. I'll upload the lectures for last Monday. Right. Continuing from where we left off just before the break tadi, we were looking at example number 3 lah, basically example number 3, and from that example we were trying to figure out dia punya reinforcement. How do we apply the reinforcement? So basically for the staircase, kalau tengok pada staircase, okay, for the staircase we have a case where this is kita punya staircase, and then we had all the anak-anak tangga sini, steps, okay, steps. Okay. Katalah saya buatkan habis. Okay. This forms the steps for the staircase. Kemudian it was without any support on one end, tapi at the left hand side kita ada beam supporting. Okay. So on the right hand side it is being supported by the landing. Okay. So kita punya schematic is that we have kita punya, this is our schematic adalah structure, okay, and our bending moment looks something like this. Okay. Untuk tangga walaupun tak direka bentuk dalam example, tapi if you have your textbook, in your textbook ada the full example dia ada. Okay. So this is something macam itulah. This is our schematic. Okay, this is the schematic for the staircase. So we have a negative bending moment, which means that kita punya reinforcement kena ada negative reinforcement to provide for a negative moment, which means theoretically we need reinforcement top side, sebelah atas, on one side sini, dan sebelah sini. Basically that is what it means. Itu yang dimaksudkan having negative reinforcement to resist the negative bending moment pada penyokong. Between support sini dengan hujung sini is to have our bottom steel. Basically dia macam ni lah. The understanding is bottom steel. So the bottom steel in blue is to resist the bending moment yang positif sini, the positive bending moment. Manakala the reinforcement in red is to resist the negative reinforcement. Okay, cuma what we can do ialah, apa yang kita buat ialah this blue reinforcement ni, okay, can now it is the bottom steel, okay, bottom steel, and then sampai di sini this bottom steel will now extend sebagai top reinforcement. Extend sebagai top reinforcement. So one side of the top reinforcement dah ada. The other side of the top reinforcement, which is this reinforcement, yang ini yang belum ada lagi. So this is what we need to add in di sini. This reinforcement ni sambung ke bawah and sambung ke sebelah sini. And this will then coincide dengan the reinforcement in black ini, saya buat di black, which is the reinforcement yang coming from the adjacent slab anchored ke dalam staircase. Something macam ni. Dan kita ada top reinforcement pada penyokong, bottom reinforcement pada pada in between the supports. And then we need to add additional reinforcement di sini, just in case di quarteri ada cracking, and this can be obtained by providing U-bar. Okay, providing U-bars. Okay, we haven't designed yang ni because dalam example, tapi if you look at your book, in your textbook ada solution yang ini menunjukkan the main reinforcement, and we can add yang ini reinforcement yang ni just to close up the gap di bawah ni, okay, with the reinforcement. Okay, to close up the gap. So this would represent the detailing for the main reinforcement for the staircase sahaja. Of course saya tak masukkan dia punya secondary reinforcement. All the secondary reinforcement would be yang inilah, to tie up balik dengan main reinforcement. This would be kita punya secondary reinforcement. Okay, having said that, kita punya staircase bahagian landing pula. Okay, bahagian landing clearly we have our landing di sini. We have our landing, and this is the beam connected pada landing. This is the beam connected sini. This is the beam connected pada landing on both side of the landing, and we have kita punya landing sini. Yeah. This is our landing. The main reinforcement untuk landing, okay, the main reinforcement for the landing will be yang inilah, yang kita dapat tadi 17H10. Saya buat warna orange lah. 17H10. That is the main reinforcement for the landing. That is the main reinforcement. 17H10 kalau tak silap. This is 17H10. Spacing berapa? Ada spacing tak? Ada. Can we calculate the spacing? We have a width lebar about 1500, lebar landing. Okay. Minus side cover kiri kanan, katalah saya ambil 30 mm. Okay. Minus bar diameter, minus 10. Bahagi 17. I have 17 bars. Okay, siapa ni? Anyone?
84, Doktor.
Apa?
84.
84.
84.
84. Thank you, Asmita. Nurul Najia. Okay, 84. Bermakna I can provide a spacing of 75. Thickness yang ini is 150. Thickness of the landing is 150. So now kita dah ada reinforcement yang ini. What about secondary reinforcement? Tertulang kedua. Nah, tertulang kedua, interestingly, remember kita punya reinforcement yang ini. This main reinforcement yang biru ni. Now, this blue reinforcement ni masuk ke dalam bahagian landing. Kalau perhatikan, if we look closely, this blue reinforcement extends into the landing itself. So, what I can assume is that now the blue reinforcement that is coming from the staircase will now behave sebagai my secondary bar. So my secondary reinforcement sebenarnya adalah the main reinforcement for the staircase. Tapi it extends into the landing and it becomes my secondary reinforcement. Again, saya mention di sini, we have our blue reinforcement, which is the main reinforcement to resist bending moment yang positif dan juga negatif. And this blue reinforcement extends into the landing. Now when it extends into the landing, it now becomes the secondary bar terhadap this 17H10 at 75. So I don't need to evaluate dia punya secondary bar anymore. Now the the main reinforcement from the staircase now behaves sebagai my secondary bar for the landing. Okay, which means to say sebenarnya dalam the first diagram ni sebenarnya ada drawing, ada bulat-bulat kat sini ni. Di bawah biru ni ada orange ni. Orange ni lah yang 17 H10 yang direka bentuk pada landing at 75. Paling bawah dia. Atas pada tu is the blue reinforcement. So that when we look at this yang ini, we look at this landing section, then the blue is on top of the orange. Orange is the main reinforcement for the landing. Okay. And finally kita again anti-cracking bar has to be provided because kita ada connection between beam dengan slab di hujung sini. There is a direct connection between the landing dengan beam at both ends. Therefore, we need to provide anti-cracking bar. And again, this anti-cracking bar can be of similar value dengan warna biru ni pun tak apa. Okay, so we can use the same reinforcement as the blue reinforcement sini. The blue bar ni, saya tukar ni lah pada biru. Okay, so this we can use the blue reinforcement as my anti-cracking bar. The blue reinforcement is the main reinforcement pada bahagian tangga, bahagian staircase. So this forms kita punya schematic of the data, walaupun teruk lah saya punya sketch ni memang teruk sikit. Okay. Tapi schematic I hope you understand because yang ini basically we're looking at simply supported punya case, okay, where we have kita punya idealized beam structure. We have our supports di sini, and we have our bending moment diagram for a simply supported case, WF FL over 8, okay, and we only need positive bottom steel sajalah theoretically, tapi we still provide anti-cracking bar at both ends between the connection dengan between slab dengan beam. There is always anti-cracking bar. Whenever there is an L beam connected kepada slab, whenever we see cases where we have an L beam connected directly kepada slab, then we need to provide this anti-crack bar at the junction between the beam dengan slab. Always, yeah? to provide provision for anti-cracking, right? Okay, so this covers kita punya third example. Finally, okay, kalau kita turn back kepada our notes, then we are coming to the last example, which is example number 4. And example number 4 ni is basically a repeat of example number 2 sebenarnya. It's a repeat of example number 2. Okay, if we look closely pada this example, we have 2 flights of staircases, 2 larian tangga. Okay, one flight is in this direction, and this represents another flight of staircase. Okay. Landing, remember, is in between the flights. Between first floor dengan second floor, we have the landing. So landing ni is somewhere imaginary yang somewhere in the middle between 2 flights of staircases ataupun between 2 floors. Antara 2 aras, the landing is somewhere in between that. Alright. Now, if we look closely, pertama sekali, let's say this is our flight number 1. This represents my flight number 1. Flight number 1. Katalah saya namakan ini sebagai flight number 1. And I have my flight number 2. Larian kedua. This is my second flight. Flight hashtag number 2. Okay. I have 2 flights. And it happens to be that both these flights intersect each other at right angles. Okay. At right angles to each other. Okay. Kalau kita study flight number 1 dulu. Okay. We look closely pada flight number 1. There is a beam. There is a beam di sini. Dan juga there is a beam di sini. Dotted line tu, indicating there is a beam supporting flight number 1. Dan similarly, there is a beam, there are two beams supporting flight number 2. Okay. So beam yang ini, this beam is at second, katalah this is at second floor, aras kedua. Whereas this blue beam di bawah ni is at first floor. So daripada first floor naik kepada second floor. So this particular beam is at first floor. Beam yang ini is at second floor. Okay. Beam yang di sini is at landing level dan beam yang biru ni pun at the same landing level. So kalau if I were to take out flight number 1 dulu, okay, flight number 1 would be represented something macam landing, staircase, kemudian kita ada slab around here. I have my beam somewhere here and my beam di sini. This represent, the blue one represent flight number 1, larian pertama. Larian pertama. Whereas the flight number 2 yang ini, saya tukar color. Flight number 2 starts from landing, daripada landing sini, and then going up, kemudian sini. Okay. I have my support di sini, this beam, and I have my beam support di sini. Yang ini. So flight number 1 dengan flight number 2 ni, both flight ada independent support. Dan kalau kita look closely, solution to flight number 1 dengan flight number 2 ni sama aja, which is exactly sama dengan our previous example number 2. Kita ada case beam and then I have my support. Okay. Support di sini, support di sini. Okay. It is a continuous case, continuous on one end, and my bending moment would be something macam ni. Untuk larian 1 dan larian 2 sama. Which is similar kepada example number 2, example 2. Sama je. Cuma sekarang ni loading, masalah loading. Okay. This particular landing ni, okay, appear di sini, landing yang sama. Okay. Appear di sini dan appear di sini. The same landing appear dalam dua larian. Landing yang sama, dalam larian nombor 1 pun ada landing, which is this landing. Okay, which is this landing, appear di sini. Dalam larian nombor 2, daripada landing naik ke atas, so landing yang sama juga. Dalam larian nombor 2 pun ada landing juga, which is the same landing. So, ada landing yang sama, appear 2 kali pada 2 different flights of staircases. Maka if this is the case, maka loading pada bahagian landing, just bahagian landing sahaja, is divided into 2. Separuh pada larian 1, separuh lagi pada larian 2. So N pada landing ni adalah N bagi 2. Untuk setiap larian 1 dan larian 2. Okay, so N bagi 2 pada larian 1, N bagi 2 pada larian 2. N over 2, the loading, the design load, which is 1.35 GK plus 1.5 QK on the landing, is now divided into 2. Half will appear in flight number 1, another half will appear in flight number 2. Basically, that is the content ataupun the context of example number 4, to highlight if we have 2 flights of staircases sharing a similar landing, and both the flights of staircases are independent of each other, meaning flight number 1 has 2 supports, flight number 2 has 2 independent supports. They do not depend on each other. They have their own independent supports. And if these 2 flights of staircases are sharing a single landing, then the loads on the landing for flight number 1 is half the actual loading. And similarly, the loads pada landing on flight number 2 will be half the actual value. And that is the main focus for example number 4. It's just to highlight that if we have 2 independent staircases intersecting and sharing a single landing, then the loads on the, logically the loads on the landing, half of it will appear in flight number 1, another half will appear in flight number 2. Itu je. That's about it. So the solution for the example is similar to example number 2. Sama saja. Cuma now the loading pada landing is now divided into 2. Okay? And if we have a look, kalau kita tengok ni di sini, okay, this is highlighted di sini. Okay. Ini semua sama, cuma landing. Okay. Landing sekarang ni, the design load for the landing, taking account of the self weight, the finishers, we have a total GK, we have a total QK. So the design load is approximately 11. Half of 11 is approximately 5.5. Now remember 5.5, right? So when we look at flight number 1, okay, remember yang ini, the load on the landing is not 11, tapi 5.5. Half the load of the actual landing. The actual landing is about 11, tapi what is used around here in this analysis, pada larian 1 dan larian 2, the value is half the value of the actual 11 kN per meter. Itu je. That is the only difference ataupun the only highlight of example number 4 to share information. If we were to have 2 flights of staircases, okay, sharing a similar landing, and both flights of staircases happens to have both flights of staircases they are happens to have their own independent support, maka the loading on the staircase is then loading on the shared landing is divided into 2, bagi 2. Itu je. Okay, the rest of the solution sama. However, ni lah yang however, if this particular solution, this particular case, however, let's say for argument's sake, kita nak bincang ni kan, saya maintain the beam larian nombor 1 ni, okay, flight number 1. Remember, this is our flight number 1 in blue. Okay, flight number 1. I've maintained the same support, flight number 1. However, untuk flight number 2, flight number 2 is this flight. This flight. This is flight number 2. The beam on one side ni masih ada, tapi sebelah sini dah tak ada beam. There is no more beam. There is no beam sebelah sini. The same problem, okay, the same problem, the same layout, the same everything, same dimension. Cuma there is no beam at this support sini, at this particular location. For flight number 2, it has one support maintained at one end and one support removed. Remove one support for flight number 2. Then the problem becomes a case where flight number 1 with 2 support is now the major flight, whereas flight number 2 with 1 support becomes the minor punya flight. So it becomes a major minor punya problem, which means to say flight number 1 is now behaving as support kepada flight number 2. Now we're talking about tangga menyokong tangga. Staircase supporting staircase. The example number 3 was landing supporting staircase. Now we are looking at a case where there is a possibility a staircase can support another staircase. How can this happen? If we have from our discussion tadi, if flight number 1 for this particular layout, flight number 1 has 2 supports, whereas for flight number 2, 1 support has been removed. Therefore, flight number 2 is handicapped. It has only 1 support. Maka it has to depend pada something else for support, and therefore flight number 2 becomes our secondary flight. Flight number 1 primary flight. Primary flight supporting secondary flight. Flight number 1 supporting flight number 2, which means we have to do a separate design pada 2 ni, 1 and 2 berasingan, which also means that reaction daripada 2 has to be transferred to number 1. Okay, number 2. And number 3, loading macam tadi, we divide the loading into 2, half-half. Provided dua-dua independent. Flight 1 dengan flight 2 independent. Now, flight 2 is dependent pada flight 1. So, loading on the landing ni, 100% will only appear in flight number 1 sahaja. Flight number 2 tak boleh, there is no loading pada landing. Similar to example number 3. Okay. So for flight number 2, kita akan ada landing. Okay. Naik. We have a support sini. Sini tak ada support. Okay. Center line landing. This is my landingnya center line. Okay. Flight number 1. Flight number 1 is from lower, naik. Okay. Lower floor, naik, kemudian banyak sangat naik. Lower floor. Susah betul buat freehand. Okay, something macam tu. Ni flight number 1, the blue flight. Ni ada beam, sini ada beam. Okay. Flight number 1 ada satu beam, tak ada beam. On the left hand side, tak ada. So loading pada sini, sekarang ni, pada flight number 1 ni, our schematic dia will be beam, kemudian support sini, loading pada landing, loading pada tangga lagi besar kan. Tapi loading pada landing ni nak highlightkan dia N, bukan lagi N bagi 2. 100% of the loading goes kepada flight number 1. Flight number 1 is the main flight. Secondary flight is flight number 2. Ini yang from a simple straightforward punya solution, now it becomes a bit complicated. Because we have a staircase supporting another staircase. Itu baru tengok loading pada landing. At the same time, sini akan ada support because this landing is supporting this flight number 2. We need to evaluate what is this V, and this V will then be added di sini pada bahagian landing sahaja. That is the reaction of staircase number 2 onto staircase number 1. So you can see the variation involved. Okay. In this typical example, we started off quite a simple, straightforward, direct problem. But if we have a closer look, if we were to remove one support, then kita akan jadi case major staircase supporting secondary staircase, and then it complicates a lot of things. Beban pada landing is no more divided by 2. Everything goes kepada the main staircase, and then the reaction from staircase number 2 has to be included dalam solution of staircase number 1. The location of the addition of the reaction adalah pada bahagian landing, because landing is now the intersection between the two. The support for flight number 2 is at the landing. And similarly, as I said, okay, the same argument juga saya boleh guna. I have my beam on one side. Okay. Yang ini tak ada. Remove ini. This is my flight number 1. Flight number 1. And I have my beam di sini, support ini, and here. And this is flight number 2. And the whole thing changes. Semua tu berubah. Now flight number 2 is supporting flight number 1. Flight number 2 has 2 independent support. Flight number 1 has only 1 support. It depends pada flight number 2 for its stability. Untuk kestabilan, it will be dependent on flight number 1. So everything tukar. Loading pada landing 100% pada flight number 2. Reaction from flight number 1 pada flight number 2. Pada bahagian landing. Okay. Because 2 is supporting 1. Tadi kita tengok 1 is supporting 2. Okay. So these are some of the variations that you might come across. Okay, we have about 10 minutes. Any question? We've come to the end of the tajuk of staircase. Have a look at the assignment. Just have a look at the assignment and try to see whether you can tackle the problem. Tak payah buat the full solution. Just look at the questions in your assignment because those are past year exams. Cuma saya tak ingat. Some of it was taken from test, past year test. Some of it were taken from past year final exams. So have a look at assignment number 1. There's a sort of question you might be expecting in your test number 1 later on. Saya pun tak tahu lagi bila tarikh dia. I'm waiting for Dr. Izni to announce when the test will be conducted. Okay. Because we will be conducting similarly for all the 3 sections. Okay. Same time for all the 3 sections. Take home, bukan take home, apa panggil? Open book test. Okay. So the test number 1 is on one of the questions will be on staircase. So have a look at the assignment, the questions in the assignment. Try to see if you can come up with the framework for solution. You don't have to proceed with the actual solution, but just to understand the direction of your solution. Rangka penyelesaian tu. Just to look at the overall framework of your solution. Okay, have a look at that because that represents the past year question, and from the lectures that we've gone through for the 2 weeks last week dengan this week, hopefully dapat memberi that will give you the right apa nama for you to the right guide for you to attempt the question. Okay? Hopefully by going through the lectures this past 2 weeks, you are now able to attempt to answer the questions given dalam assignment, in your assignment. Okay? In your e-learning ada. You can just download from the e-learning. Any questions from anyone? Nurul Najiha, ada soalan?
Ada, Doktor.
Ada. Okay. Anyone? Anyone else? Aznita?
Tak ada, Doktor.
Ada. Wan Haziq? Yong Zeng Go, ada soalan?
Ada, Doktor.
Okay. Alright. So, okay. If you have any questions, just interrupt saya saja. You don't tak payah tunggu saya tanya apa semua. Our next lecture tomorrow will be bukan lecture lah. It will be more pada discussion, and hopefully we'll have a look at the project work. We are about 6 minutes lagi. Okay. Your RC project work, your IDP. Hopefully you already form your groups. Dah ada group ke tak ada? Maybe some of you dah ada groups. Yeah, another half belum ada groups. So try to form your group as early as possible. Kalau boleh by tomorrow morning, semua masing-masing dah ada grouping. And we'll have a look at the project work. Saya pun belum tengok detail lagi. But from my glancing through, it's about I think a 2-story building, bangunan 2 tingkat, sekolah. It is U-shape, bentuk dia U-shape, and I think that tak ada sangat critical elements that you need to look out for in the project work given. Anyway, we'll have a more detailed discussion tomorrow. Okay, some of you were able ataupun were fortunate enough mungkin masa intern to be involved using software application in design, RC design ataupun your infrastructure design. Okay, some consultants dia ada so many software untuk earthwork, software untuk sewerage, software untuk drainage. Okay? Ada consultant yang dia ada satu software, semua boleh buat. Earthwork boleh buat, sewerage, drainage, water supply, semua boleh buat, all the infra. And then not to mention the software software for building, and not just RC, ada steel, ada RC, ada mungkin hybrid pun ada. So IDP 2 will encourage students to use software, especially dalam RC, software application. that will come in IDP 2. So make use of the experience and the exposure that you had during your intern. For those fortunate enough lah. For those yang tak dapat berpeluang, it's okay. Maybe in your group members ada yang berpeluang dapat pengalaman. So it might be a good idea to get untuk buat your RC. Dalam IDP tu ada 5 tajuk kan. Why not buat RC and partner with someone yang dah ada exposure during the intern. So you can, walaupun intern tak ada pengalaman design, tapi you can gain a lot of experience by applying software application in design. Cuma bila doing your software application in design ni, walaupun saya tak mengajar IDP 2, one element that I usually stress kepada students, bagi stress pada student, that I would like to stress to the student is that if you're using software, try to achieve a solution yang terbaik, which means that once you have finished your design semua, put some value added dalam your work. What if you change the concrete grade from 25 ke 30? What would be the implication? Katalah looking at just one component. Tak payahlah tengok semua. Looking at foundation sahaja. What would happen if you have finished design semua? Grade 25 katakan. So what you're saying is, what if now tukar kepada grade 30 ataupun 35? Would there be any savings in terms of reinforcement? Would there be any reduction in terms of size of reinforcement bars ke, ataupun bilangan reinforcement bars ke, spacing of reinforcement bars ke? Would there be any positive results by increasing the strength of the concrete? Just by FCK daripada 25 tukar ke, it's just a matter of few buttons kan. So what I'm trying to say pada student is that if you are using software in design, bukan manual lah, in design, using software, then explore all alternatives. Tukar grade concrete, ubah dimension of your beam, ubah dimension of your column, tukar exposure condition, all those things you can do just by a few buttons kan. Okay, and let the software do all the work. So you can even plot a graph. Kalau saya lah, plot the graph. Column versus concrete dimension. Okay, ubah dimension berapa bilangan? Ubah dimension, you can plot the graph. Foundation, concrete grade versus number of bar. Itu pun tukar. You can start with 25, 30, 35, 40, 45. And look at the amount of reinforcement and you can put up a graph kat situ. So these are value added areas that you can explore dalam software application. Because it's you're make the software work for you. Tapi kalau manual janganlah kan. Nak tukar concrete grade, you have to start all over again kan. Nak buat design dia. Okay. This is for software application. So a lot of exploration can be done. You can explore banyak benda lah when you're doing. It doesn't need to have a 10-story building pun tak apa. It's a simple 2-story building pun. Tapi explore what you can optimize from your design by making use of the software. Apa yang boleh kita optimize? Is it the concrete grade? Is it the dimension? Dimension of beams, columns, slab dan sebagainya. Okay. Is it the layout? By changing the layout of your columns, will that improve your foundation loading katakan? By changing the layout columns dia, tukarkan tiang ni, will that improve will that reduce the column design punya loading, and therefore you have a better design dan sebagainya. So a lot of things that you can do with your software application dalam IDP 2. Tapi dalam RC2 is all back kepada our manual calculation. Right? So, any other question? Less than 1 minute. So,